Good morning, dear friends. I am Dr. Rajin, Linus, Associate Professor of Electrical Engineering Department at Sanjay Godavat University, Kolhapur. Under this power electronics simulation series, we are going to learn about today type D chopper. Type D chopper, in the sense we have the two diagonal switches and we have in the other side two diagonal diodes, and how it will operate. That's what we are going to learn. Already we know this type D chopper is first quadrant and fourth quadrant chopper. That means current is always positive, but voltage will be changes based on the duty cycle. Let me share my screen so that you can easily understand with explanation. So this is, we have this type D chopper. Type D chopper, in the sense we have we have one switch, two switches. This is the good, and we have one diode here. Then we have one switch, then another switch here, then diode. So we can call this is switch 1, chopper 1 or chopper 2. Then we have this voltage Vs. This will be positive, negative. In between we have the load, resistance and inductive load. So this is diode D1 and diode D2. Then here if this terminal is positive, this terminal is negative, output voltage is positive. So this terminal is totally for output voltage positive. Then current is, if this direction, current will be positive. Otherwise, vice versa, voltage is negative and current is negative. For example, when the chopper 1 is on, when the chopper 1 and the chopper 2 is on, chopper 2 and 1 and chopper 2 are on, what will happen? Current, how the current flow will be? When these two are on, current flow will be like this. Current flow will be like this. Therefore, we have output voltage is also positive. This is voltage and this is current. So output voltage is positive and the current is also positive, right? Then when the chopper 1 and 2 is off, chopper 1 and chopper 2 is off. If the chopper 1 and chopper 2 is off, what will happen? We have inductor will store energy. This inductor will, when the inductor stored energy, we have this this terminal will be positive. When the inductor stored energy, we have this terminal is positive and this terminal will be negative. Whenever this inductor discharge release the energy, this polarity will be reversed. Here it will be positive and this will be negative. So in this case, what happens? Stored energy in the inductor, it will freewheel through the source. It will feedback to the source. So now polarity, voltage is negative. At the same time, current is positive, right? Same direction. Current is in the same direction as like previous case, but the voltage will be negative. So in this is the called as current is positive and the voltage is negative. This is our fourth quadrant. So we are going to do these two cases for two cases. Then another one concept is, whenever del is greater than 0.5, on time of this chopper will be more. If you refer the books, you will come to know that the chopper, on time of chopper is more when compared with to inductor to release the energy, time for releasing the energy. That time we have average output voltage will be positive. Then whenever del is less than 0.5, inductor will get the time to release the energy. So that time our average output on time will be less, off time will be more. So that time output voltage will be negative. If you refer the books, you can easily understand. However, this negative voltage is based on the inductor. So if the inductor value is very less, there is no energy, there is not having much energy to release it. It will store, it will release a small amount of energy. Otherwise, it will release more amount of energy. So that till that we will have this more output voltage. We will have this current flow will be there. Otherwise, output voltage will, more current will be there. So now let me share my simulation file. So for example, this is the circuit. In this circuit, we have two switches. Two switches will be simultaneously on. That is what I have connected this duty cycle with this circuit as well as this circuit. Similarly, I need this duty cycle waveform for analyzing, so that I have connected with this scope. Then in between I have connected one load, resistance is 100 ohm and inductance is 3 millihenry. Then input voltage I have chosen as 240 volt. So this is the load terminal. These two are diode. I have connected as per the circuit what I have explained already. Let me run the simulation for duty cycle greater than 0.5. Let me take for duty cycle 0.8. What will happen? We have this. You can no need to run the simulation till some time. So to run the simulation, we will come to know that see on time is more, off time is less. So what happen? On time will be voltage will be more, off time this inductance value is very less. Therefore, voltage across the inductor, once it will release and again it will start to current will start to voltage, output voltage will be positive. That is why. So see this till this voltage current flowing through the inductor will gradually increase. Before the next chance to charge the inductor, this inductor will store the energy, it will release this energy and it will come down. Current already going to minimum value. That is why we are not at all getting proper output voltage here. Some otherwise we will get this exact square waveform. So inductance values also based on the inductance values, this will change. Then similarly, if you use this duty cycle of 0.4, otherwise 0.4, run the simulation. Then here the duty cycle, see this is 0.4. On time is maximum, off time is more. On time is maximum, off time is more. But here also we can see output voltage is positive only. Why output voltage is positive? Stored energy in the inductor dissipated fast, then it will wait to charge. Still that inductor voltage will be zero. Voltage across the inductor will be zero. Then again voltage across the inductor will increase. Then current will increase. Start to increase here. So that here also output voltage will be positive only. But based on the inductor value, let me check this inductor of maybe 9 millihenry. Some changes may occur. It will take some time to inductor releasing time, energy releasing time will also increase. Let me check whether we are getting this value. Sometime this voltage is little more increased, but however this voltage across the inductor, polarity of the inductor totally, average output voltage will be negative as per our theoretical assumption. But moreover the stored energy in the inductor, here this side will be positive and the left side will be negative, therefore automatically voltage will be negative. But the current direction is same as this previous cases. That is why we will call it as first quadrant. Type D chopper is we will call it as first quadrant as well as fourth quadrant operation. So in real time applications and in our simulation, based on the inductance, we have to choose higher inductance so that we will get high voltage span. So from the waveforms we can easily understand. So average output voltage is negative. Other cases, based on the stored energy in the inductor, once the inductor release the energy, the voltage across the load will be automatically negative due to the polarity change of this inductor. So with this, I will conclude today's presentation of type D chopper. I hope this topic is understandable, and based on my knowledge, just I am sharing this. Maybe it will be very helpful for BTech students. Those who have not subscribed yet, kindly subscribe this channel. Wish you all the best. Thank you.